Okay, let's take a scenario, then we'll discuss about that. Oh, do you remember what we have done last class? I don't remember it. Okay, good. So we have not done the packet capture and then analyze it? Oh, okay, okay, fine. Okay, let's take a small scenario then. I have like a switch, and then I have so on that day what you have done is ARP, right? Let's try to understand something else today. I have system A. I also have, let's assume that, let's have a router as well. I have a router here. So this guy has an IP address of again the same 10.0.0.10, and then let's say 10.0.0.1. This is the IP address of my router 1. So for the management purpose, if I'm going to do a telnet from system A to router 1, how this connection is going to be established? So first of all, it will start doing this telnet connection. So let's start doing the packet capture, and then we'll start the analyzing the. Let me. I think I have updated this one. Meanwhile, let me start the machine. Now I could do the packet capture from my base machine, but it will be giving lot of unwanted packets. So that's the reason I'm just taking a separate machine where I'll be generating my interesting traffic, and that alone could be captured, and you can avoid lot of some unnecessary frames being viewed in the packet capture. So I could also go with my IP settings as per my requirement. So my diagram says that the router is supposed to be configured with an IP address of 10.0.0.1. That's what I'm going to be doing it now. So that's the IP address I have configured and enable the interface. Now I'm just getting into okay, it is in 10.10. Perfect. So I just need to go and enable the password. Uh, okay. So I have set up a password of Cisco and username of Cisco and password of Disco, and I ask the login to be checked against the local database so that when someone is doing the telnet, it will be collecting the username and password and validating against the local database. Now I have a machine with an IP address of 10.0.0.10 where I'm just going to be initiating the Wireshark packet capture. Of course, you can also initiate the packet capture on your GNS as well. On which interface you want? Can you see this one? Start capture. I can do that one. But anyway. Okay. Now let me go on interface. On which interface? On VMware interface. For that, no ARP entries are there. So I can simply go and start the packet capture while it is going on. Telnet 10.0.0.1 and is asking for the username as Cisco and password as Cisco. So I can see from which IP address the telnet session has been initiated. So once I have established the telnet session, I'm just going to stop the packet capture and then I'm going to be interested in watching what happened. I'm just going from here. Why? Because there was no ARP. This is what that day we have seen. So the MAC address of 10.0.0.1, yep, since the 10.0.0.1 I'm not aware of it. So because of that, it is asking for the MAC address of 10.0.0.1. So 10.0.0.1 is replying back with his own MAC address. After that, what is that going to be happening? Because telnet uses what port number? So we know that TCP 23 is the port number is being used by telnet. So because of that, we know TCP connection oriented communication is going to be initiated, for which 3 packets are going to be exchanged. Do you remember what are all those packets? SYN, SYNAC, and DAC. These 3 packets needs to be exchanged, right? So let's see, those 3 packets are there: SYN, SYNAC, and DAC. And then it would have taken for the username and password. So once the username and password has been given, and you would have taken a session. So the point is, we don't want to discuss here about the app because that we had the discussion on the last class. Now the TCP three-way handshake process is happening. So can you please tell me about what is your understanding or what we had the discussion on TCP three-way handshake process when we were discussing about the OS LAS? Whatever you could remember. Okay. Uh-huh. Okay. Okay. How about Synac? What will be there? Okay, good. Uh-huh. 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 Okay. So what sort of acknowledgement is that? Uh-huh. Uh-huh. Okay. Our packet capture is ready. We don't need to worry about it. Let me select this. So first of all, whenever a connection is being initiated with, okay, let me take the case of a telnet. What is that going to be happening? A telnet data is going to be created, right? So that's what my data. So let me call this as my data, right? So of course, it starts, telnet is an application acting at which layer of OSI? It is acting at application layer of OSI. Of course, it will start constructing the layers like what? Physical layer, sorry, application layer, presentation layer, and session layer, which we don't have any focus now. Application, presentation, and session layer. All three layer covers are being kept on top of the data. Now on transport layer, it is interested in filling up and identifying the services as well. As we know that this is going to be my TCP. TCP, the source port number could be what? Anything greater than 1023. So I'm just picking up 1050. Right? The destination port number is what? TCP 23. But before this could happen, what is that? The TCP port number things, it has to make sure that the server is live and available for me or not to establish a session. So because of that, it is going to be starting this three-way handshake process where it will be sending the SYN packet. Of course, the source and destination port number is going to be the same. Source port number and destination port number is going to be there in your packet. The source port number can be greater than 1023 and the destination port number is going to be TCP 23. The first layer, what you could see on the packet capture of the SYN packet, can you see this one, the SYN packets? What is the first header you are seeing it? Layer 4 header. Whereas in telnet, you can see many things. The telnet has the data, whereas in your TCP three-way handshake process, you don't have the telnet data. Can you see that? So the TCP content, the TCP, whenever the SYN packet is being initiated, there won't be any content at all. It is just to inform the receiver that I would like to access the service one is available on your machine. And if you could manage my connection or if you could process my request, then you reply me back with the certain parameters. What are those parameters? That's what we are seeing now. So the first packet, what is that? SYN packet is being sent. The SYN packet is being sent with no data. The first layer is what? Layer 4 header. In layer 4 header, what is that going to be kept? No data is there. So of course the source and destination port numbers are being set. So my source port number, let me pick it up, 1050. And the destination port number is what? 23. TCP 23 is what the port number, right? And inside the TCP header, what do I do? So I'm just going to feed some details like what? And this is the first packet of my session. So I would like to synchronize my connection settings with you. So that is being set as what? SYN. Okay. So what all the flags are there in the TCP header? You remember anything related to that? So by seeing the TCP header value, the receiver could understand whether the packet what I'm receiving is part of an existing connection or the client would like to open up a new connection or any other information could be exchanged to it. Let me say the TCP header as SYN ACK, then hello, you remember any flags? Okay. Okay, URG, PSH, CWR, ECN. Okay, let me see whether those flags are being shown here or not. Basically, you can see, can you see this one? One, two, sorry, congestion window reduced, ECN echo, urgent, acknowledgement, push, reset, pin. You see this one? 1, 2, 3, 4, 5, 6, 7, 8. Right? We are not discussing about these two. These are not considered as a regular flag. Right? Nonce and reserve we are not discussing here. Basically, there are 8 flags. What are all they? Congestion window reduced, which is nothing but the CWR, ECN echo, urgent pointer, acknowledgement, push, reset, and pin. SYN is for what? We know that one. If a client would like to access a service which is available in the target machine based on TCP, it has to synchronize something. For that, the client is sending a SYN packet to him. Right? And whenever it sees the SYN packet, it could go and recognize what is the sequence number of that client request. Why? Because the client is going to be constructing many packets, and they are going to be numbered from this particular sequence number onwards. That's the reason the SYN packet's the sequence number is called as what? Initial sequence number. Does it make sense? Okay. So SYN packet is for what? Synchronizing the parameters with the server. What is that? Right? SYN packet is for what? Synchronizing the sequence number. And that's the reason it also has a different name. What is that? Sequence number synchronization packet. So the SYN flag is going to be set as 1 from the client side. So whenever the server receives this request, it could understand that one, the client is trying to open up a connection with me. I need to check, do I have enough resources with me? If I have enough resources to accept this connection, it has to reply me back with his own set of initial sequence number. That's the reason these two packets, both of them are called as what? SYN packet as well as the SYN packet. But anyway, the SYN from the server is a response to the request SYN packet. So obviously TCP is going to be an, what is it called? A reliable protocol. So whenever it is sending back the SYN packet, it also going to say that I have received your SYN packet, so I am acknowledging that one. What kind of an acknowledgement is going to be carried out? Okay, let's assume that the client has sent a SYN packet with a number of 10, okay, something like this. 10,000 is the sequence number, the initial sequence number set by the client. So the sequence number of the server, that could be anything. Let me take it as 20,000 as the initial sequence number of the server. And what would be the acknowledgement here? Acknowledgement, the flag is going to be set as something, but anyway, the acknowledgement is also going to be for the sequence number what we have received, correct? Is that correct? Yes. Okay. I think you have to review. Fine. So the acknowledgement of TCP is not for the packet what we have received. The TCP uses, exactly. So that is called as what? And the type of acknowledgement we call it as forward acknowledgement. Right? So since I have received the packet number 10,000, so the acknowledgement number is going to be what? 10,001. So when client receives this packet, it knows that the server has enough resources and he has accepted my connection request. The only thing what I need to do is to acknowledge the SYN packet so that I can inform the server that I have synchronized your initial sequence number. So the third packet from the client to the server is an acknowledgement with a number of what? 20,001. We know that the acknowledgement of TCP is forward acknowledgement. If these three packets have been exchanged, they could have opened up a connection. From that point, they will be able to send and receive the actual data. Let's see that one in, what is that called? In packet capture. So TCP says that it is a SYN packet. How do we know it is a SYN packet? Because inside the TCP header, we have set the synchronization flag to 1. That means what? That means what? It is meant for synchronization. So the server, whomever receives this packet, it is going to be knowing the sequence number of the client. But in normal packet capture like Wireshark, if this is going to be allowed to capture and see in the initial sequence number, that could lead to many problems. In the sense what? If an attacker could capture and see the initial sequence number of a connection being established, he could easily predict what will be the initial sequence number of next connection. Let me say like this. Let's say I have a machine and which is connected to a network, or it could be a LAN or it could be a internet as well. Assume that I have a machine here and this is my server. This is my client. I also have a guest. Okay. Now, whenever a SYN packet is being sent, by the client, it is going to be having an ISN. Similarly, whenever a SYN packet is being replied back by the server could also be sending something called as what? ISN. The server will be having the ISN packet. An initial sequence number will be there. Somehow, if an attacker could capture that packet, he knows that the initial sequence number of the server. Of course, if he could capture this packet, he also knows the initial sequence number of the client. Doesn't matter here. The interesting point is, if he could read and understand the initial sequence number of the server, he can predict what would be the initial sequence number of the next connection request. Assume that the same client could open up a new connection. It could be a different client as well. The same client is trying to open up a new connection. The server has to reply back with is a SYN packet. What would be the initial sequence number of this new connection can be predicted by seeing the previous initial sequence number. Do you understand what I'm saying? Okay. So what an attacker could do, he could send an acknowledgement for the next connection initial sequence number. So to avoid this kind of a prediction, what would be the initial sequence number of the next connection, whenever you do the packet capture using the Wireshark, this initial sequence number is going to be called as a relative sequence number. It is not the exact sequence number. Something like, I don't know how the system happens in Pakistan. If someone is writing an examination, say you have a public exams and all, right, like in India. So 10th standard, +1, +2, those things are there, right? Okay, so if a candidate is appearing for an examination, so they have to put their enrollment number. When it goes for the correction, that number is going to be removed, a matching number. It's not the exact enrollment number, a dummy number will be added to it. So this could avoid the paper chasing kind of a concept. That means people can go behind people can go behind the executives and they can pay money and say that this is my enrollment number, can you put some extra mark for it? So when that enrollment number is being replaced by some other number, it would be very difficult to identify whose paper it is. The similar kind of a concept, I don't want my initial sequence number to be seen, to be visible for any of these attackers. So what a Wireshark as a precautionary measure it does is this initial sequence number is going to be a relative sequence number. So just by seeing the relative sequence number, you couldn't predict what would be the initial sequence number. So because of that, this could be avoided. So whenever you do packet capture, the initial sequence number would be a relative sequence number, and that could also be what? 0. What is that? This is a SYN packet, right? The initial sequence number is what? 0. Can you see this one? So in our case, what is that happening? The client is sending with initial sequence number of 0. Similarly, the server will reply back with initial sequence number of 0 as well as an acknowledgement as what? 1. Because server received sequence number of 0 from client, it has to send an acknowledgement. The acknowledgement is nothing but the next packet what the server is expecting. So because of that, the acknowledgement number what we would see is 1. Let's see that one. So the TCP SYN packet is the SYN flag is set, and what is that called? The 0 is the sequence number. For the response from the server would be what? Of course, it is also a SYN packet, SYN flag is set, as well as an acknowledgement is also set. So when the receiver receives, he could understand this is the response for the request what we have sent. And you could also see the initial sequence number of the server is 0, whereas the acknowledgement is what? 1. And that is also not the exact acknowledgement number, it is a relative acknowledgement number. Why? So we are changing that value so that we could avoid some attacks. Is that clear? Okay, so yes, it is there. I'll come to that. Now we are trying to understand the TCP's behavior, not the Wireshark's options. Yeah, okay. Correct. Okay. So the final packet from the client is what? The acknowledgement. It is not being set as SYN. The SYN flag has not been enabled. Instead, acknowledgement field alone has been enabled, so that you can see the acknowledgement value is 1, but the sequence number is also 1. Why? Because that is the next packet the client is sending back. So when the server is receiving this packet, it can see the packet number 0 was SYN, packet number 1 is an acknowledgement, so it could confirm that the connection has been established. So in this scenario, you need to understand the TCP's connection has been established. Connection has been established on which port number? So TCP, what is the port number it has been using client? 1043. So client's port number is 1043 and the server's port number is 23 of TCP. So the connection has been established and they can start communicating it. So since it was asking for the password, the username and password, you can see this one. The telnet data. User access verification is going on. What is the username? It is asking for the username and we started giving the details. We started giving these details. Can you see this one? P, I, it would be going for I, S, T, O. That's the username we have sent it. So in Telnet, every character is going to be sent individually. So when you do the packet capture, of course, you can see everything and it would have been asking for the password. Password is going to be what? D, I, S, T, where is that? O. Can you see this one? O. So the problem with Telnet, this is what? The communication is going to be in clear text. When someone is doing the packet capture, they can easily get the username and password of that session. That's the reason we normally recommend instead of Telnet, go for SSH. And the point is, we normally say telnet is clear text, whereas SSH we normally call encrypted telnet. So what is, then why do we have to worry about it? So if I go for SSH, is that protected? Okay, let me say a small example of it. Let's say that the client has opened up a session with the server, the telnet session has been established. The attacker could easily go and launch an attack called as what? A session hijacking. So what is the benefit of it? The attacker no need to go for cracking the password or cracking the username and password. All he can do is he has to wait until the connection is being established from the client and wait for the username and password to be fed by the client. So once that is done, the attacker could simply hijack the session from the original client to the attacker machine. So on your client machine, what will happen? On client machine, what will happen? The window what he was using go unresponsive. He could go and open up a new connection with the server. That is possible. But anyway, the existing connection, whatever has been opened, since it has been hijacked by the attacker has gained access to the server now. So to avoid this one, we say that SSH would be used or SSH needs to be used. But again, the problem with this, what is that? It is not a problem at all. So by encrypting the telnet traffic, we call it as an SSH. It doesn't mean that we could prevent the session hijack attacks. It is still possible. Then why do we have to go for SSH then? Okay, so assume that I have a router again. I have a router and then I have a client. I also have an attacker. Now with the help of SSH, if I open up a connection, what is that going to be happening? Since SSH uses asymmetric algorithm, a key is going to be negotiated between these two people. Right? That key is going to be stored in the buffer of the client machine. So when a session is being opened up, the key has been negotiated, we opened up a connection and any data from between the client and server or the client and router is going to be encrypted using the key what we have buffered. So even though the session could be hijacked by the attacker, since he is not aware of this client, the key what has been negotiated between the client and router, he wouldn't be able to see what is being seen or what has been basically what I'm trying to say, the window what he has which has been hijacked from the client, it will be having some junk values because the data what we are receiving from the server is being encrypted using the session key what has been negotiated is not known to the attacker, so he couldn't decrypt it. Basically what you see is some junk values. So because of that, SSH is being recommended. So SSH is not going to be avoiding you from session hijacking attacks. Okay, anyway. So this is what we need to understand. So whatever the command that I have executed, I could see what has been done. So I have given something called as what show, or so then I have said who, right? WHO. When I said who, I would have received some information, the IP address of it. Can you see this one? This is the data has been given by the server to me. So everything can be packet captured and then seen. Okay. So probably I don't know whether I have given this information to you or not. When I say open up a connection with client, how many packets are being exchanged? 3 packets, correct? Okay. So when I say exit from the connection, I would like to close the connection properly. How many packets will be exchanged? That's it. Mm-hmm. Mm-hmm. Okay. 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 Now, let's say that someone is sending a FIN packet. It could be anyone, right? It could be sent by the client or it could also be sent by the server, whatever it might be. So in my case, I'm just saying that one, the client is sending a final packet. FIN stands for what? Final packet. But why someone has to send a final packet? Because he don't have any data to be transmitted and he would like to send this information to the server stating what? I would like to close the connection because I don't have anything pending from my side. And this information is coming from the application side. So let's say that this is an FTP application, correct? This is an FTP application and it is saying that I would like to close the connection. And this information would be available in application layer's header. I don't have any more data. Let me say like this. But anyway, the final packet flag is going to be set in transport layer. Right now, the TCP header has the transport layer. The TCP transport layer has the TCP. TCP has the header in which we are setting up. This is the final packet for the communication. But the thing is, of course, you have network layer, data link layer and physical layer which is being forwarded to the receiver. The receiver has to receive the packet and then he will be processing the application layer and then data link layer and then the network layer and then finally when it comes to the transport layer, he realizes that the client would like to close the connection. Correct? Can I say yes or no by now? How can I say? Because I don't know. I may have some data to be sent, for which I have to take the permission from my application, which is there on top of my application layer. So at transport layer, by seeing the TCP FIN packet, the receiver cannot take any decision. He cannot say yes, he cannot say no. So it has to go to the application and then application has to respond back with yes or no. This could cause some delay, right? This could cause some delay. So whenever a final packet is being seen, final packet has been seen by the receiver, he knows that to process, to approve or disapprove, I need to wait for a period of time, which will lead to some sort of conclusion from the client. What is that? The final packet would have lost because I have not received any reply. Yes or no? So to avoid this kind of a conclusion, the receiver receives the final packet, he will send back simply an acknowledgement. So this acknowledgement is not for closing the connection. What he will say, okay, I have received your final packet, but please keep wait because I need to take the permission from my application. Now the application, now by this time when the final and acknowledgement packets have been exchanged, the connection has not been closed at all. It is still open. So after taking the permission, the client says, okay, go ahead and close it. Let's say that this is the final packet which has a sequence number of 1501. Okay. Right? So it will be expecting 1502. The acknowledgement from the server is what? 1502. My point is, so after taking the permission from the application, the server is trying to close the connection. By that time, it has to send another FIN packet. This is the final packet from the server and also it is going to be pointing the same acknowledgement number. So that the receiver knows that, okay, you have sent a final packet to me. Now I'm acknowledging, I'm also accepting it. Do you understand this? Yeah. So 1501 was the final packet from the client. So server receives it and he sees that one what? Okay, it's a final packet from you. Let me give you an acknowledgement immediately, but you have to wait for a period of time. So once Once the application says go ahead and close the connection, it sets the TCP final flag as 1 and the acknowledgement as the previous acknowledgement what we have sent. So when the receiver receives, okay, we have sent the packet number 1501 as the final packet. Now it is getting acknowledged as well as the final packet has been given. Approval has been given to close the connection. The only thing what I have to do is what? A simple acknowledgement with the same sequence number of what? 1502. This is what is being expected by the client. So the acknowledgement is going to be 1502 for the final packet what we have received. You understand this? Yeah. Okay. So these are all actually for closing the connection gracefully, 4 packets will be exchanged. You could see that also. Let me open up a connection. Right, 10.0.0.20. Perfect. Now I'm going to be starting an FTP server in 10.0.0.20. 3C daemon. Let's open up a connection. And then before that, we will do a small packet capture over there. Without saving. Let's open up FTP 10.0.0.20. Anonymous. Okay. So I have given some commands. And then I'm trying to say bye. Bye is nothing but closing the connection. Okay. So once the connection has been closed, stopping it. Okay. Let's go to the final packet here. Can you see this one at the last? The moment I say bye, the command has been converted into what? Quit. Right? So the quit is going to be initiating the final packet. Can you see? This is the final packet. The final packet has the sequence number of what? 247. This is the acknowledgement set as well as final. The acknowledgement is for the previous packets, what we have received. Right? So this is the final packet is being sent. Final packet is being sent for which I'm receiving a simple acknowledgement. Can you see this one? Simply acknowledgement, it is not FINAC. So the final packet has been sent by the client for which I'm receiving the acknowledgement from the server because it has to wait for the approval. So once the approval has been given, FINAC is coming up. Both of them will be having the same acknowledgement number. Can you see this 248 for the first acknowledgement? The second acknowledgement, second packet also has the acknowledgement number of what? 248. Right? And for which we receive an acknowledgement packet from the client with a sequence number of 248 because that is what the packet is being expected by the server. Right? So for opening up a connection with the server, in case of a TCP, 3 packets will be exchanged. To close the connection gracefully, 4 packets will be exchanged. Is that clear? Okay, good. Okay. So that leads to a little bit of understanding on TCP. The rest of the flags, okay, we have done with, what is that? Tin, ac, and fin. In these four flags, where is that? Fin, 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 ac, fin, RSC, ECN. Where is that ECN? Oh, kept it here, right? We have 5 more flags, and we will discuss these flags in our next class. Okay? Till this point is clear, huh? Or you have any questions to be asked? Okay, okay, fine, fine, fine. I will upload it today.